So, hey everyone, first session of DevFest South Africa, day 2. We're going to be talking about material design in Jetpack Compose today. As Ahmed mentioned, I'm Nick Rout. I'm a developer advocate at Google, and I focus on material design on Android. I'm pretty much everywhere as @RickNout, but that's another story for another time as to why I use that as opposed to my real name. So let's get going. Today we're going to take a look at material design in general, especially modern material design, I would say, since it was first introduced alongside Android Lollipop, including the design system and the existing MDC-Android way of implementing material design in the view system. We'll then take a look at an overview of Jetpack Compose, and then dive into Compose material, which gives us things like components, theming, and dark theme, as well as material icons. We'll then take a look at how you can interrupt between Compose and the view system, and in particular, MDC-Android and Compose with a new library that we recently published. Lastly, I'll give you a sneak preview of an example app I'm working on, and then wrap things up and have some Q&A. So let's get going. First up, material design. So we're going to first look at the design system and how it looks today in 2020. So from material.io, it is a design system backed by open source code that helps teams build high quality digital services. So material, as you may know it, does rely on this metaphor and these foundation principles of surfaces, elevation, and really things that kind of relate to the real world. And it recently brought in aspects of color, typography, shape, and motion in the form of animations. And together, these things all come together in the form of comprehensive guidelines for your mobile apps, intended to be used and applicable to all sorts of scenarios, not just Android applications, but the web and other areas like Flutter and iOS. So it's a comprehensive set of guidelines for everything from icons to screens to widgets on the screen to how you move between those screens, and generally speaking, the entire UX and UI of your digital product. These days, while we have these founding principles that have stuck around since the beginning, I like to see that material is split into these 4 key pillars. For what it's worth, these are also the key principles and criteria for this year's Material Design Awards. So those will be announced sometime later this year. But we basically can split it into material components. These are the individual building blocks that make up your screen in the form of widgets. And then we have material theming, material dark theme, and material motion. So as I said, components are these building blocks that allow you to create screens. They're everything from things like app bars to cards to chips to sliders, radio buttons, etc., etc. There's a whole host of them at material.io/components, and you can go and explore what each of these components are meant for and where they are applicable to use. Next, we have material theming. This is the idea that you can take the baseline look of these components, which we saw on the previous slide is this purple rounded corner, and uses Roboto as the font, and apply material theming to them to fundamentally change their look and feel, but still keep the same components. So in this case, you can see a few examples of how we're changing the shape from rounded corners, for example, to cut corners or square corners, the color, as well as the typography, and how this gives you an almost infinite variety, even given the same component, the same baseline component. Next, we have dark theme. And dark theme is really building on these 2 principles already and adding some additional guidance for how these components should adapt to a dark theme environment, with things like muted colors to reduce eye strain, and then also surface elevation, which indicates, and surface brightening to indicate elevation when you can't see shadows. Lastly, and the most recently introduced, is material motion. And this is really a set of transition patterns that allow you to move between your screens once you've built them up using these components, material theming, dark theme, so that there's a clear, consistent flow between your apps. That was a brief look at material design as it stands in 2020. But now we need to also consider what we currently have in order to implement this on Android. And that's in the form of the Material Components for Android library, aka MDC-Android. So this is available on GitHub and really is a single package that you can add to your Android app, which has the package name com.google.android.material and is meant to go hand in hand with your Android X libraries and offer you material components, theming, dark theme, motion, and everything else that I've just mentioned to practically implement in your app. For what is worth, this replaced at some stage the now deprecated and older design support library, but this is definitely the one you should be using if you're still on the Vue system. So I'm not going to dive too much into what this library does because there's comprehensive guidance out there, including our new material blog, which has posts on how to migrate to material components if you're still on the design support library, things like implementing material theming in terms of color, typography, and shape. You'll find things there on motion and soon dark theme as well. But let's take a little look at what they look like because this will become important later when we compare it to Jetpack Compose. So in material components, you can add components to your XML layouts like so. In certain cases, you can see how these buttons use the same button tag that you may be used to, but just use a different style attributes in the form of contain buttons, text buttons, and outline buttons. Alternatively, at times, there are new classes. So here you can see that they use the full qualified namespace for things like cards, text fields, and this new extended floating action button. You can see the difference here perhaps is that in the previous case, it's using the same XML tag, whereas before it's using the new class name. Material components can also, or certain material components from MDC-Android can also be used programmatically. So in this case, we're showing a snack bar. It doesn't really make sense to include this in an XML layout, as well as a dialog, which needs to be shown in a modal way. Material theming and dark theme can also be implemented with MDC-Android. So the latest guidance that we have is to store your colors, typography, and shape in separate XML files in your res/values folder, which really are going to define the theming values that you can then add to your app theme. Speaking of your app theme, in order to support dark theme, we have this structure which we recommend, which allows you to set up a base theme to add your non-color based material theming attributes, and then extend that for color using this theme.app.base as the parent, and then adding in your color attributes that we declared before. Importantly, we can duplicate this in our res/values night folder, which allows us to support dark theme with MDC-Android, and then the library really does the rest. Finally, this is something that you would then use in your manifest. You'd apply it at an application level to go apply to the whole app, or perhaps at an activity level if you want different themes per activity. So this is kind of how this works. It's a very brief overview, but essentially these material components, which are in the form of views and widgets from MDC-Android, reach into your context, find these attributes that you've declared in your themes, and then apply them to the button, giving you the ability to transform this baseline component into something that looks more like you've declared in your custom theme. And this could be anything. In my case, I've got a button with square cut corners and a navy color, but it could be anything in terms of shape, color, and typography. Finally, material motion with MDC-Android. And I'm not going to go into a whole lot about this because I recently gave a presentation about this, and I advise you to check out my Twitter. I posted the slides, and I will soon have a recording of that talk up as well. So that was a brief overview of MDC-Android. I really did go through that quickly because I don't want that to be the focus of this talk. The focus of this talk is going to be Jetpack Compose and how this compares to MDC-Android, and also some of the benefits that it offers over it, but also some of the shortcomings that it currently has as a result of it being in alpha. Compose. If you haven't heard already, Jetpack Compose is the new UI toolkit offered by Android. It is under this new androidx.compose namespace, and you should definitely check out developer.android.com/jetpack/compose. This is sort of how it looks. It's pretty much a brief overview of how Jetpack Compose works compared to what you know already. Essentially, it's a declarative UI toolkit. So everything in Jetpack Compose is a Kotlin function. So you don't have XML, you don't have Vue.java files or extensions of those. You don't have the separation between the UI and how you statically declare the UI and then the logic related to it. Everything is done in these app composable annotated Kotlin functions, which then brings you into Kotlin world and gives you a whole host of cool new features and allows you to interrupt with other Kotlin things like coroutines. This example here is pretty simple, but you can see how nesting composable functions allows you to create UI in a very succinct way, and I think very intuitive as well. The main thing to note here is that in terms of getting into Compose world when you're on Android, is quite simple. You may already, or you probably are using an app compat activity already for something like your main activity. And in order to get into Compose world, we offer this set content extension function, which basically is going to get you into Compose world in the activity and replace your set content view where you may apply a layout or a view. So that's a brief overview of Jetpack Compose. Once again, I do definitely recommend checking out the documentation, and I'll offer a whole bunch of more links and resources at the end. But it's safe to say that this is the future of Android development, and it is the new UI toolkit that is getting most of the focus and is rapidly evolving at the moment. Part of Jetpack Compose is that it has a package called Compose Material. Jetpack Compose dependencies are very granular. They're split into things like foundations, layouts, interop with things like architecture components like live data. There's also things for animation. But the one that I'm interested in the most and the one that I'm going to be focusing on today is Compose Material, which is essentially two different packages that Compose offers that are going to be implementations of material design. So the first thing we have is androidx.compose.material, and then this is just the main material package. This offers you material components as composable functions. It gives you the ability to do that same material theming that we saw earlier with MDC-Android. It offers dark theme support out of the box. However, at this stage, it does not currently support material motion because of the fact that transitions as a framework is quite a big thing to port to Compose and isn't currently ready. The next one is a smaller package, which is material icons. This essentially just gives you all of the material icons from material.io/resources/icons, gives you all of those styles, fill, outline, rounded, two-tone, and sharp. And these can be used as vector assets with the icon composable function. What's interesting to note here is that this is the main UI part of Compose. And something that I'd like to point out is that MDC-Android is built on years of legacy in Android when it comes to, if you consider we've got the Android framework, we've then got app compat built on top of that Android framework to make things backwards compatible, things like views that have features that are only available on a certain API level. And then MDC-Android is built on top of that. So when you're choosing a button, you kind of have a few options, which can be a bit confusing, especially for beginner developers. You could choose the framework button, you could choose the app compat button, or you could choose the material button. And in Compose's case, they chose to build their UI layer or their widget layer, you might say, with material from the get-go. So instead of being an opt-in to material system as it is now with the view system, this as a result of legacy, really you get material by default and you can opt out of it, but I think that really makes things a little less confusing and gives you only really one option to start with. So let's look at how you can implement components, theming, and dark theme in Jetpack Compose. So the biggest thing to point out here is that in your activity class, which we saw earlier, which allows you to set content, you would need to wrap any or nest any composable code that you want to write, be it your list screen or your grid of cards or something else in this material theme composable. This is going to provide ambient material theming values for other composables to reach up to and find. So this is essentially like declaring a theme on your application class in your manifest or activity. It's going to be declaring a material theme the entirety of the Compose code that sits within it. In this case, this is the stock material theme composable function. So this is going to give us those baseline purple and white values that you saw earlier. But we'll make a custom app theme later to see how we can customize this in a way that's quite similar to how you would do it with MDC-Android. But let's first take a look at some material components and how we use those in Jetpack Compose. So here's 3 basic examples. As we saw earlier with MDC-Android, we can declare buttons, contain buttons, outline buttons, and text buttons. Unlike before, where we're using the same class in the layout and then declaring different styles on that class, Compose makes it quite, it really specifies these as separate composable functions, which allows you to, I think, avoid confusion and also gives you the ability to have the strongly typed, clearly visible types of buttons that we have here. So in our case, instead of button with some kind of a style on it, we have button, outline button, and text button. What's interesting to note here is that unlike the view button, this does not extend the text view or include text at all. It's really just a container for other things that could go in it. So in our case, you're putting a text composable inside this because that would be the text label of the button. But if you wanted to add an icon, you would have this in like something along the lines of a row. But really, this button could host anything, which is quite a powerful part of Compose that allows you to customize how a button might look and feel. Here are a few more components. In this case, we've got our same card, text field, and floating action button that we saw from before. The card is really simple. It's really just a container which acts as a surface for other content. A floating action button is quite similar to a regular button that we saw before. Instead of hosting some text within it, we now have an icon. And we'll get back to those icons later when we have a look at the material icons package. The interesting one for me, though, is the text field. And I'd like to point out a few things here about the text field. Namely that it's relying on this probably unfamiliar thing called state. And in Jetpack Compose, this is quite an important concept where by using state, we basically provide values to composable functions that can then act as flags for Compose to recompose and call these functions again. This remember function here allows us to survive or have state survive across recompositions and remember their value so that when you next call this function, it doesn't like go into an infinite loop or something. So in our case, we need to use state to basically store the text value that the text field has, the text that you're actually typing in, and then update and rerun the composable whenever it changes. This may sound like something that could be inefficient, but in actual fact, it's done in a very efficient and smooth way that allows you to have performant UI. This final example shows our snack bar. Oh, sorry, not final example, but this example shows our snack bar. And again, there's a few things going on here. We still have this idea of remembering states, but a couple other things here I'd like to point out. Firstly, the string resource function is a convenience function offered out of the box in Compose. It allows you to reach into the existing resources that you may have in your app and then get them into Compose world as strings or other forms of things that Compose understands. So in our case, we needed 2 strings resources for both the message and action on the snack bar. Another thing to point out is this is using coroutines. So here you can see how we have a coroutine scope, which is actually stored as state. And in order to launch and show a snack bar, we use coroutines along with this other component called the scaffold. This is part of material, Compose material, as a way to almost, you can imagine it as an equivalent to a coordinator layout, which allows you to host various things like app bars, bottom app bars, floating action buttons, and also snack bars together and to interact and have them anchor on each other or be positioned properly or float above the content like a snack bar does. The last example is a dialogue. And this is really making use of most of the things I've already showed you already. It's making use of state, which is really just a Boolean to say whether we should show or hide this dialogue. It's then also just passing through a few parameters like string resources for a title and a text message. It's then using buttons as ways to confirm and then dismiss the dialog. You can see how in the confirm button and in our on dismiss request, which is essentially tapping outside of the surface of the actual dialog, i.e. the scrim, we change the value of the state, which will cause a recomposition and will cause this composable to run again, thus hiding the dialog. So that's how material components look in Jetpack Compose, but how do we actually implement material theming? We don't want to be using the baseline purple look and feel on our app. We want to customize it so that it matches our brand and adds some individuality to the apps that we are building with Compose. As it turns out, it's quite similar to MDC-Android, and many of the concepts that I showed you before do come across. So if you're familiar with that, it's great because then you can take that knowledge and transfer it with minimal friction. So while in MDC-Android, we had a separate XML file for colors, typography, and shape, here we'd have separate Kotlin files and declare colors, typography, and shape. In our case, we're using, instead of XML tags and items and nested sort of XML nomenclature, here we've just got classes like the color class or the typography class and the shapes class to wrap our theming values in. And these are all provided by Compose material for you. Then we'd have something like a theme.kt Kotlin class. And here we're using something which allows us to group colors together into two separate light and dark color palettes. I should point out that these two functions are quite important. They're essentially provide the default baseline light theme and dark theme colors, and you can override whichever ones you want. Otherwise, it will use the default values from the baseline purple theme. We then want to set up our app theme. This is what I hinted at earlier when I said we would be replacing the existing material theme composable with something of our own. So this is how you do it. First, you make a new composable function called, in our case, app theme. We pass two values to it. Firstly, this dark theme Boolean, which has the default parameter as set to is system in dark theme. This I'll speak about in a minute. The second parameter is our content, which is going to basically be everything inside the composable function that falls under this app theme. So this is the rest of your UI. This is system in dark theme is a convenience function provided once again by Compose material, which really allows, gives you the ability to quickly check, as the name would suggest, is the system in dark theme, and then apply some Kotlin logic from then on. So in our case, we do want our app theme to follow the system dark theme. You can imagine a case where perhaps you have different logic, like dark theme based on certain flags or a user preference, or maybe you have logic that allows you to pick between more than two themes. But in our case, we do want to change the theme depending on light or dark. And here you can see how those two color palettes we declared earlier can be switched between in a way when you're using this Boolean. Finally, the last thing we do is once again use that material theme default composable, but in this case, add some parameters to this function, namely the colors, typography, and shape, and then pass through the content. What this then allows us to do is, in our activity, instead of using material theme here, we just use app theme in the exact same way. And this will give us a custom material theme with different colors, different typography, different shape. It still follows the system dark theme. And this is now going to theme our app as we had before with MDC-Android. If you're looking to retrieve these material theming parameters at runtime or in other parts of your app, and like in other composables that perhaps need to apply some custom logic, you do it in this way. So this is using this material theme ambient, and it's going, and you get the option to extract colors, typography, and shapes. And this notation here can be used almost anywhere. And so long as you've wrapped the code and that particular version of the place in the Compose tree in a material theme or a custom material app theme like we made, this will work and grab things like your primary color, your button typography, or your small shape component. This is quite similar to if you have, let's say, in an XML layout, an attribute where you use the question mark attra slash and then mention an attribute in order for you to basically grab an attribute level value as opposed to a value directly. The next thing I'll look at is icons. So icons are relatively simple. This is that additional compose material package that I mentioned. And these allow you to essentially declare icons and all of it pulls in all of the icons from material.io/resources.icons so that you don't have to copy those in, convert those SVGs to vector drawables, and then fetch those from resources. These are all bundled for you and then give you all of the styles, which is really great. So you have the default style, which happens to be filled, but then you've also got outline, rounded, two-tone, and sharp. They're intended to be used with this icon composable, which, as the name would suggest, is almost like a primitive for an icon. And you can also apply a tint to this icon. And you can see in our case how we're using that same notation for grabbing the on-surface color from our current material theme and applying that to the icon. So that was a look at material components and material theming in Jetpack Compose. But in most people's cases, while you may start an app from scratch in Jetpack Compose, that is definitely something that may happen. There's going to be cases, I think, when people have slower migration paths where they have existing apps that they want to slowly start adding Compose to. So in this case, you've probably got an existing app using the view system. And then I would hope you're using MDC-Android to implement your app's theme and various bits of your UI and widgets. In this case, we need to explore a few ideas of how you can use the view system and Jetpack Compose together, and in particular, MDC-Android and Jetpack Compose together. First, some general interop theory. The first thing I will say about this is you should 100% watch this video from my two colleagues. And this is Compose for existing apps. It goes through basically everything you need to know about using Compose and views together, but other things such as interoping with existing architecture components, testing, and various libraries that can help you with your UI when you're in a world where you have some views or some screens or parts of screens in Jetpack Compose and others in the view system. The one thing that I would like to point out from this, which I think is the most interesting for me when I've been converting one of my apps to Jetpack Compose, is the ability to host Compose code in an existing view hierarchy. And that would use this Compose view class that you can see here. You'd add it to, for example, your layout and give it an ID. Then in something like your fragment, you grab this Compose view, use that same set content method that we saw in the activity, and then you're in Compose world again. Alternatively, you could construct one of these programmatically and return it in your fragments on create view, and then your entire fragment, for example, would be in using Compose. Another thing I'd like to point out is this a new library that we recently published. It's called, it's quite a long name, but it's quite a simple library at the end of the day. It's called MDC-Android Compose Theme Adapter. As the name would suggest, it's a library that enables the reuse of material components for Android XML themes for theming in Jetpack Compose. So you can grab it on GitHub. But I'd like to say here that this is essentially going to allow us to have one source of truth between an MDC-Android declaration of a material theme and a Compose declaration of a material theme. You can imagine, I guess, a state where you're trying to convert your app to Jetpack Compose, and you have an existing material theme with all your values set up, color, typography, shape, a bunch of attributes that you've overridden. And you could recreate that in a Compose material theme, as we did earlier with that app theme example. However, this library offers you something slightly more convenient. So instead of declaring an entire app theme and constructing that from scratch, what we can do once we've imported that library is to simply use this MDC theme composable. This is really the notation. This is all you would really do with this library. It's basically a single line replacement. And what it will do is reach into your current context, be it in your activity or in your application, and then look for material theming parameters from MDC-Android. So it will go in and fetch things like color primary, or text appearance button, or shape appearance small component. Store those values and convert them into a custom composed material theme for you, so that you don't have to write any additional theming code while you're doing the migration. Once again, I will say that if you're making an app from scratch, you definitely would need to write your own custom app theme. But if you've got one already that is mostly using the view system and you don't want to have to recreate it in Compose, this is a great way to make this migration super smooth and allows you to have your theming parameters available immediately. The next thing I'd like to introduce is this an example app I have been working on with a member from the Android Studio team. You may or may not be aware, but material design is present on Figma in this Figma community. We love to use Figma; it's a great tool, and we have this Figma community so that people can see our latest guidelines and things like these material design sticker sheets. So here on this page, you can see two things that I'm interested in here. Namely, it is the sticker sheets of both baseline and dark theme components. This is really a way in Figma to get an overview for basically almost everything that material design offers, all of its components combined in different ways so that you can see how they work together, but also get the sort of zoom out level view of material design as a whole in both the baseline light theme and dark theme. And in Figma, what you can do is you can change some of the theming values like the color primary, color secondary, and change and see which components adapt to these and react to these changes that you made in your app's theme. So when I chatted with this member of the Android Studio team, we decided that it would be a cool idea to recreate these sticker sheets in Jetpack Compose. What that would allow us to do is to have the ability to see where Compose is at in terms of its coverage of material design, you might say, and also give us a way to find feature gaps and also be able to report bugs. But importantly, it also gives us an interactive project in Android Studio that is essentially very similar to what you get in Figma. Similarly, you could change the theming values in this app and see changes to your Jetpack Compose code and see how material theming affects these various components. It also gives you the ability to see this in preview, not just by running on a device. So it's quite a powerful concept, I think. And this is a little sneak preview of what we're working on. It's not quite ready to share with you just yet, but essentially it's going to be an interactive app that has the same things that I showed you before on this page, but just implemented in Jetpack Compose entirely. And the one benefit here is that it is also entirely interactive. You can see how clicking on things gives you ripple feedback, sliding sheets, etc., etc. So do check out my Twitter for that. When it is ready, I'll definitely let you know. But we're hoping that this is going to be an exciting foray into how sticker sheets and these sort of test screens that a lot of people tend to have in their app to showcase their design system can easily be implemented in Jetpack Compose and can in some ways be superior. So that is all from me today. I'm going to offer you a few more resources now to look at, and then we're going to open it up for some Q&A. So I do want to, however, give you a verdict on what I think in terms of material design and Jetpack Compose as it stands now. So the view system and MDC-Android currently are more mature and do offer better coverage of material design. Of course, they've been around for longer, they've been a little more battle-hardened, but they do offer other things like material motion transitions that just Compose currently doesn't have. However, Compose is the future. It is the new UI toolkit for Android, and it's something that you should definitely be trying out at this moment. It's an alpha, it's evolving rapidly, and now is pretty much the time to try it out and give feedback as it approaches something like a beta and stable release. In terms of additional resources for both material design and Jetpack Compose, there are many. You will definitely want to be checking out material.io. We have an Android developer page, and we also have a new blog. We do have a YouTube channel coming very soon as well, so do keep your eyes peeled for that. In fact, I recently streamed and recorded a video where I went through the process of converting an existing app screen to Jetpack Compose, so watch out for that. Next, there is, of course, a ton of awesome Jetpack Compose resources. So the main page is developer.android.com/Jetpack Compose. However, there are other things. You would definitely want to look at the class reference for Compose material. This is going to give you all of the available material-related classes in Compose at the moment, and also is going to give you great documentation on how each one of those is used and implemented in a Compose app. Then there's a bunch of these links which gives you access to the Compose documentation, samples, and I should point out here that most of the samples use the material studies as bases, so things like Crane, Rally, and etc. are implemented in Compose, which is a great showcase of what Compose can do. There's awesome code labs, and then there's also a link to that MDC-Android Compose theme adapter library I spoke about earlier. And with that, I'm done, and that is all from me today. However, I would like to open it up to the floor for questions. I'd also like to say a big thank you to the virtual audience out there for attending and for taking part in Jadiji DevFest South Africa. So with that, I'd like to say, are there any questions? And I'm happy to answer them.
Hey, Nick. Awesome talk, man. The material design stuff always gets me excited and always gets me, it puts me in anticipation of wanting to use it in my own apps, and definitely going to try out what you've spoken about. So thanks, man.
No problem.
We do have some questions. It's actually just 2 questions. So the first one is from Maya Khutapus. So she asks, what app architecture would you recommend for ensuring that it test when using Compose?
Easy to test. Well, app architecture-wise, I would say Compose is slightly more geared towards single activity. While there's interrupt things for things with existing UI components, like things like fragments, or hosting and view hierarchies, really at the end of the day, I guess the ultimate goal is to just basically have a single activity that hosts composed code that has enough logic in it to switch between various composables as screens. Everything is kind of open source, so I don't think it's been officially released yet, but there's a bunch of integrations coming out now for things like the navigation component, which allows you to navigate between composables to abstract that sort of logic. Then other integrations with things like the paging library, which are coming soon as well. So from an architecture standpoint, I think that's probably where things are heading. In terms of testing Compose, there was actually a great talk that was recently given by Jose Alfereca. He's one of my developer advocate colleagues at Google. He knows a lot more about testing Compose than me. In fact, that is his focus, and that was the focus of that talk as well. So I'll find a link to that, and I can drop that, because I feel like that would be a far better answer to the testing question than I would be able to give.
Cool. And but as far as like MVVM, MBI, which pattern do you think would work well?
Right. I think, and this is kind of my opinion. So in my experience, I came from it was MVVM world. I went for quite a vanilla, what Google currently offers you architecture. It would use something like live data. It would use the repository pattern. It would split up your view models as well, basically all from architecture components. So in doing that, I've kind of come into that and tried to apply Compose to that. And it seems to be going quite well. There's integrations for things like converting view models, live data to Compose state. There's like basically a ton of extension functions that allow you to observe live data. It's literally called observer state, which gives you the ability for like when something in live data changes, it causes a recomposition of a composable function. And then you're kind of like in the same world as before. I haven't really thought too much about like if I was making a Compose app from scratch though, what architecture would I use? And in that case, I get the feeling that it's flexible enough to handle whatever you may choose, actually. And there may not at this stage be any kind of like best option.
Sure.
Once again, it's pretty early. It's alpha, and I guess these questions are going to be answered as it matures and as people start using it. So, yeah.
Cool.
Yeah.
Cool. Thanks, man. Okay, so the second question is from Anselmo Alexandre. So he asks, Nick, it is a great talk. Congrats, man. I'm using an shapeable image view along with material shape drawable to set its background, and it works, but the shapeable image view doesn't apply padding on it. And the custom shape doesn't look that great like those other widgets like Fabs. How can we correctly apply background on shapeable image view?
Well, for those who don't know, shapeable image view is a widget class offered by MDC-Android. So this isn't in Compose. And it's really just an image view that allows you to apply shape theming to it. So in a similar way to how you may apply shape theming to a button on MDC-Android or a card where you use the attributes like shape appearance, you can then do this on this image view. And really what it's great for is like applying rounded corners to a photo or making a circular image, which I guess we've always had to use separate libraries for and other sorts of things for in the past. This is quite handy. In terms of the actual question, I would need to see the implementation if I'm being honest. I've used it to good effect on my own, and I guess what can sometimes happen is that you think you need to set an Android background on this thing, which is like kind of the perhaps more intuitive way, but what you really should be using is app shape appearance, and then passing through a shape appearance style, which mentions a corner size and a corner family, or maybe like a top left corner. I guess I would advise, I'm just going to be honest here, I know Anselmo already, and please, dude, reach out to me, show me your code, and I'll be glad to have a look at it, and we can try and debug your issue. Related to padding, sounds like you might be onto something there, so if it does end up being an issue after we have a look at it, we can always just file a bug on the MDC-Android GitHub repository, and I can then let the team know so that they can take a look at it.
Sweet. Thanks a lot, Nick. So that's actually the only questions that were posed, and I guess that makes Anselmo the winner of the prize. So Anselmo will be getting in touch with you. You have an awesome prize coming your way. Nick, as always, it's great hearing your talks, and thank you so much for this great talk, man.
Yeah, thank you so much for having me. It's been an awesome experience, really smooth. One of the better virtual conferences I've been to, and I really hope that the rest of it goes well and that everyone enjoys the sessions. I think it's going to be some seriously amazing content coming up. So yeah, all the best.
Thanks, man. See you.
Cool. Bye.